This is video number 4, page 2, problem number 7. A slice of pizza has a central angle of 42 degrees and the diameter of the pizza is 20 inches. Find the length of the crust of one piece of pizza. Round your answer to the nearest tenth. And it gives us the formula that we need to use. S equals R theta. As we saw in the first video, I know that R is my radius. And since they give me the pizza in terms of diameter, I know that the radius is half the diameter. So half of 20 inches is 10 inches, my radius. Theta is my angular displacement. And here's the key part, in radians. So they give me an angle of my slice of pizza of 42 degrees. But I don't want degrees, I want radians. So I'm going to change that to radians by multiplying by pi over 180. That becomes 42 pi over 180. If you're trying to simplify this on your own in terms of pi, I would put the numbers in your calculator and then tack the pi on at the end. So 42 divided by 180, math, enter, enter, gives me 7 over 30, and drop your pi in. So 7 pi over 30. And it's as simple as that, just plug right in. S equals the arc length equals my R, 10 inches, times my angular displacement, 7 pi over 30, which becomes 7 pi over 3, or it tells me to round my answer, so I should just assume that I'm going to give the decimal form. So 7 pi over 3, which is about 7.3 inches. Let's move on to problem number 8. Number 8 says, if theta is between 0 and 2 pi, find all the values of theta, meaning there's several of them, which make the following statements true. Not all may have two answers, but draw the angle locations on the circle provided. Again, as I said in the previous video, you need to be very careful of which dot you're going to use for your angle location. Okay, so for A, sine of theta is negative square root of 3 over 2. I know that sine is y over r. So I need to think, okay, where is it? Well, first off, where is sine negative? Sine is my y value, and y is negative in the third and fourth quadrants. So that means that sine must be negative in those quadrants as well. So I'm going to ignore everything in the first and second. I'm going to focus on the third and fourth. Now I also know that sine is my vertical distance, and my vertical distance is a length of square root of 3 over 2. So if I'm thinking about my reference triangles, let's say it's in the third quadrant, this length right here has to be negative square root of 3 over 2. That would make this angle our larger angle between the 30, 60, 90 triangle, besides the 90 degree, which would make it 60 degrees. I could also say that I know that this is negative square root of 3 over 2, so that would make this side negative 1/2, and opposite my shortest side is my shortest angle, and I have my reference triangle completely labeled besides my radius. Here is my reference triangle. My reference angle is the one that's pointing at the origin, which would be this angle right here, so 60 degrees. 60 degrees is the furthest dot away from the x-axis, closest to the y-axis. So my terminal side for my angle is that third dot closest to the y-axis. Now, as we said very many times, your unit circle is symmetric about both your x and your y-axis, so it's going to be the same distance from your y-axis in the fourth quadrant. So our angle in the fourth quadrant is also the closest to the y-axis, a reference angle of 60 degrees. We're not done yet because we need to find theta in terms of pi. If I know that this is 60 degrees, I can also say, instead of 60 degrees, that's pi over 3. If I'm starting on my initial side at the positive x-axis and I'm going all the way around, how far is it to the pi over 3 in the third quadrant? Now you could memorize which pi over 3 angle is in the third quadrant, or you could count. If this is 0, I know this is pi, or 3 pi over 3, one whole, and then an extra pi over 3. So that would be 3 pi over 3 and an extra one, which would give me 4 pi over 3. You could also say that my pi over 3's are right here, and just count around. This is 1 pi over 3, 2 pi over 3, 3 pi over 3, and 4 pi over 3. If we're finding the theta in the fourth quadrant in terms of pi over 3, you could say if this is the 2 pi, that's the same as 6 pi over 3, and it's 1 less than that because we haven't gotten to that yet. So 1 less than 6 would be 5 pi over 3. Or you could say it's the next one from the 4, add 1, or count all the way around. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. And again, you could also put it in degrees. Figure out the degrees first, and then convert it to radians. So in degrees, this would be 240 degrees, and this would be 300 degrees. 240 degrees changed to radians gives me 4 pi over 3. 300 degrees changed to radians gives me 5 pi over 3. So that problem was a little tricky, and it's kind of messy, but you can generally see where I'm going here. For B, cosecant is undefined. What do we know about fractions that are undefined? Well, that means that it was a divide by 0. So the 0 has to be in the denominator. If I'm dealing with cosecant, cosecant is the reciprocal of sine, which means it's r over y. So my y value has to be 0. Where is y 0? On the x-axis. Here and here, the positive x and the negative x. Now we don't have a reference triangle that we can use here, but we know, as we did with problem number 6b, our radius is 1, so our distance from the center of our circle to the outer edge is 1, and this is across, so it's going to be the x value. And as we just said, the y value is 0. If we're going left, that's going to make the x value negative. So where are we right here? Well, we haven't moved yet. We're on our terminal side. We're on our initial side. So that theta is 0. The negative x-axis, as we know, is pi. You could have also stated 2 pi as an answer. Now on your test, you won't have the option of choosing 2 of 3. Your inequalities up here will be more specific, saying not 0, but including 2 pi, or including 0, but not 2 pi. So just be careful when you're working on those. So cosecant is undefined when y is 0. Y is 0 on the x-axis. That's at 0, and pi, and also 2 pi. And I will continue problem 8 in the next video.